Hi everyone, and welcome to my tutorial on creating game models from video via Photogrammetry. In this video, I'll be showing you how to take a video of an object and turn it into a game-ready model. All the software I'll be using is freely available on the web, and I'll be providing links in the description. Please note that I won't be going into details about the ins and outs of each of these programs, as that's far too much to fit into this tutorial. Instead, I'll be showing you the overall process from start to finish. Firstly, let's talk about capturing the video. Only certain types of subject can be captured via photogrammetry, and only when lit by diffuse lighting, i.e. no direct sunlight. So when capturing things outdoors, capture them on overcast days, and if you're indoors, don't have any powerful direct lighting like spotlights. Also, you can't capture anything transparent or reflective, as this confuses the algorithms used by the software. Capturing for photogrammetry traditionally involves taking a great deal of photos from every conceivable angle, so I find it easier just to take a video, although please note that pictures will normally be much higher quality, but it's a great deal more time consuming. Make sure when recording your video to move around the subject several times from different angles. You're trying to record all parts of the subject. Also, try and move gently without any sudden moves. Here's the video that I took of a rock that I'd like to turn into a game model. You can see me changing angles all the time. Please note that this is obviously sped up quite a bit. The software we'll be using to do the photogrammetry only accepts still images as inputs, so we need to grab individual frames from our video. Load the video into VLC and pause it. What we need to do is to grab frames without any motion blur and the overlap at least 50%. Use the scrubber to scrub through the frames of the movie, looking for ones that are better quality without any motion blur. When you find the frame you like the look of, press Shift and S to take a screenshot. You'll see that little preview appear up there. Do this throughout the whole video, ensuring that the frames overlap and are good quality. One thing I'd recommend is to change the snapshot directory, making it easier to find your screenshot files. Tools, Preferences, turn on Show All settings, and then I believe under Video, Snapshot directory. There it is. Now that we have all our images, I like to take an extra step which is purely optional. And that's in Krita, I load up all my images and I delete all the extra pixels that I don't need. Now, you don't have to be remotely accurate when you do this, and in fact you want to leave a little bit of the surrounding image around your object so that the process later can bed down the edges. You'll see what I mean later. And then I just select the opaque, trim to selection, and I save the top of the old image and proceed to the next one. I'll go and do this with all the images and then we'll proceed. You'll notice that with all the images, I always trim off the excess transparency. and that's because the less pixels we have for the photogrammetry process to process, the quicker it'll be, and believe me, that's a good thing. Next, we'll create a dense point cloud using the COLMAP program. So load that up, then create a new project, select the folder with your images in, and create a database file. I create mine one above the image folder. Database. And save. Now run the processing feature extraction. I leave those on default options and press extract. This will take a few seconds. Once that's done, processing feature matching. Again, default settings, press run. It shouldn't take too long. That took about 2 minutes. Once that's done, we'll move on to reconstruction, start reconstruction. And you'll start to see a sparse point cloud being made. This again will take a few minutes. Now that that's done, let's have a look at our point cloud. It's looking good so far. You can see there's an area possibly down here in the bottom of the rock that's not got enough points. So ideally you'd go back and take some more imagery of this area. But the nice thing is because we've made a video of this, we may be able to find different frames in the video that would fill that gap in. I'm not going to do that now, so let's continue. At this stage, it's a good idea to save the project. So save project as, and I'll just call mine project. Now we'll move on to the dense reconstruction. So reconstruction, dense reconstruction. Select a folder for your workspace. I shall just create a new one here called dense. Select, and then click understored. This again will take a little time. There we go, not too long. And then the next step is stereo. Now this will take a very long time, like an hour or two depending on your computer speed, and your computer will become unresponsive when it's doing this, so go and have a cup of tea, watch a movie, or do something else. Let's set this going. Once that's done, just move straight on to Fusion. Again, this will take a while, but not as long as stereo did. Once that's done, you could theoretically do the meshing in COLMAP, but we're going to move on and do that in MeshLab. The last thing to do here is to save our bundler file. So if we export model as, choose bundler, and then I find that putting this inside the dense images folder helps later on. I'll just call this bundler, save, and we're done in COLMAP. Our next step is to use MeshLab to create the high-res mesh and its texture. So first we'll go to File, Open Project, and select the bundler file we just exported in COLMAP. And then you also select the list file. This loads in all our camera positions for use later. Then we'll go to Mesh Import, and in the Dense project we'll find our fused file. Let's import that. And there is our dense point cloud. Already looking pretty cool. Now, before we proceed, we want to get rid of some of these extra points that we don't want in our model. To do this, we'll use the point selection tool, drag out a rectangular region, and then press the delete points tool. Again, you can see that there are some regions of the model that are somewhat lacking in points. We'll just proceed and see how it goes. Right, so we need to convert this into a mesh from points, and we do this with one of the filters. If you go to Meshing, Simplification and Reconstruction, go down to Screened Poisson Surface Reconstruction, and here I'm going to leave everything default apart from reconstruction depth, and I'm going to take it up to 9 to make a more detailed model. Be careful taking that too high because it really makes a lot of polygons. So we'll try that. Press apply. This will take a few seconds. Now that that's done, let's hide our original fused mess. And there is the result of that operation. That's to be expected, that's strange underneath. It's just trying to smooth the faces over to connect any holes. You can see here there's a little bit of a low res piece of geometry. We'll have to have a little think about that, but the rest looks pretty good. So this looks like it's got a kind of a low res texture on it, but in fact it's not. It's vertex colors, and we want to get rid of the vertex colors and change over to a high res texture. So let's get rid of these vertex colors. Make sure you've got the right mesh selected. Go to Filter, Color Creation and Processing, and Vertex Color Filling. And I'll change that to a white color and apply. And there is a blank white model. So next we'll apply the textures. To do this, all we need to go is to Filters, Texture and Parameterization plus Textures from Registered Rasters. That's just a fancy word to mean that it's using the textures and the camera information from Coalmap to make a final texture. So I'm going to up that resolution to 2048, press apply, wait a few seconds, and there we have our high resolution textured mesh. That's looking pretty sweet. Before we export our final mesh, it's worth getting rid of a few polygons that we don't want. So, like before when we used the Select Points tool, we'll now use the Select Faces tool to draw rectangular regions around faces we don't want, and then delete those faces away. So a lot of this underneath isn't needed, so I'll do the same thing. We don't want about that much, let's try that. That's better. Oh, I see a few little bits of rubble lying around I don't want. So again, I'll just select them, delete. And that is unfortunate. That'll sometimes happen, so remember to save your work often. Right, there we go, back to where we were. So, last thing to do is just to export your mesh. And I'm going to use OBJ format, which is pretty much standard. And let's call this Rock High Res. And press save. We don't need color, but normal and texture coordinates we do want. Press OK. It'll take a couple seconds. There we go, and that's done. Now, the final stage in our process is to make our game model. So in Blender, we're going to import the OBJ, and there's our high-res rock, so we'll import that, and this will take like a minute because it's such a lot of polys. Now that that's in, let's position our rock a little better. So I'm going to go to side view, rotate it around, so the front, do that a bit better, get it in the position. Okay, there we go. Then I shall put the pivot in a sensible place. That's better. And I'll actually save this as a Blender file and work with that from now on. And if we want, we can have a look at the textured view just to check. Oh yeah, that's looking really good. So the first thing we want to do is start making our low-res version. So I will add a new object, starting with just a single vertex, and we're going to turn on snapping to face, and also project individual elements onto the surface of other objects. And this means if I grab this point, move it around and let go, you'll see it's snapped to the surface of our high-res model. I'll just rename this as low-res rock. Oops. Then we'll just start extruding from that point to make our low-res mesh. And you'll see as we go, it's all it might be hard to see actually, but it's snapping to the surface. To make this easy to see, if we go to the Objects panel and turn on Xray, our lines will now show up even if they intersect the other mesh. Right, and if I select that edge loop and fill, we'll get our first face. Again, if I turn off the X-ray mode, you'll see we only get to see a little bit of it that's sticking out, but X-ray makes it easy for us to see what's going on. Now I'm just going to carry on doing the rest of the model. Right, now that that's done, good idea to save it. And then we'll move on to UVing our low-res mesh. So I'm going to switch it to solid view to get a better, yeah, that's better. And then I'm going to do this by marking seams. So edge mode, and I'm just going to quickly mark some seams up. Okay, we'll start with that. Mark seam, unwrap. Let's see what we get. Let's try and get a better usage of those UVs. Okay, that's our UVs done. And with those done, it's time to move on to baking our texture over. So we'll select all faces, assign a new image. I'll call this diffuse. Then on the baking panel, make sure you've got the mode set to textures and select it to active. Select the high res rock first and shift click the low res rock and press bake. In a second or two, we'll get our diffuse texture. Then you want to save that out. I should just call it diffuse. Save. The other texture we need to make is the normal map. But before we go there and do that, let's have a look at our model again. If we hide our low res, and I'm going to turn on matte cap shading. I'm going to choose a nice glossy shiny one. Okay, so if we look, most of our model has a nice bumpy detailed surface, but there was an area over here where there wasn't enough imagery in our capture, so we've got a rather featureless corner. So what we're going to do now is improve this area by hand to the Sculpt mode. Turning on dynamic topology. You don't need to worry about the UVs because and the vertex colors because we've already baked our color map over, so that's okay. Disable any symmetry and make sure that smooth shading's on. It already is, that's great. So this is just a case of trying to rebuild what you remember your object has in this low res area. So I'm just going to you want to give it the same kind of resolution of texture that the rest of the model has. And there we go, we've done a nice job of putting that detail back in. So with that done, it's time to bake out our normal map. So I'll bring back our low res mesh, and at this point I will ensure that it's set to smoothed faces for the correct baking of the normal map. We will give it a new image again, so we'll go to the UV editor, select all, let's see, yeah, give it the new image. I'm going to call it normal this time. Select our high res rock, then our low res rock. Make sure that the baking mode is now switched to normal, so press bake. Great, there's our normal map. and then, like last time, save your image out. I'm calling this one normals, save image. And then of course the final thing to export is our actual object, our low-res mesh. And just for simplicity's sake, I'm going to just delete the high-res one and then export as an OBJ rock.object. Export. There we go. So that should be all the assets we need to create this rock. And as a final step, I've just loaded it into Unity and assigned the textures, and as you can see, I think it looks absolutely great. If I move the light around, you see the normal maps working really, really well, and I think we've got a really good asset. Well, I hope you all find that helpful. Thanks for watching. Bye.